I've got up here on the board the quotient rule for taking a derivative of two functions. Okay. Now, in some of the check-in assessments and possibly on a quiz at some point in the future, we might explore a little bit why this is true. We could do a proof very similar to what we did for the product rule, where if I were to do that on a quiz or an exam, I would do the proof myself, but ask you to explain the reason for some of the steps. Okay? What I'm doing in these videos is I'm just going to give you the rule and we're going to practice using it. So it looks incredibly complicated. The derivative of f divided by g is g times f prime minus f times g prime all over g of x squared. Now, I will point out that just like with the product rule, we're building things out of our four functions. F and g, the two originals, f prime and g prime, their derivatives. Similar to the product rule, on top I've got these pairs where each pair is one original times the other derivative. Of course, we're subtracting here, and I am horrible about memorizing formulas that involve subtraction problems, because I can usually remember what the pieces are. I can never remember which one I'm subtracting from which. So there was a time when I was teaching calculus and I did not have the quotient rule memorized. Once we learned something called the chain rule, it's possible to combine the product and chain rule so that you never ever have to use the quotient rule. And I just always did that. Now, I taught quotient rule. I could derive it, I just couldn't remember it. Okay. And then a friend of mine taught me a poem, and now I can use the quotient rule. Oh, it's wonderful. Here's the poem. Low d high minus high d low, square the bottom, away we go. Oh, it rhymes. I like poems that rhyme. Okay, low. That stands for the bottom function. So the one that's on bottom was g of x. D high, that's the derivative of the one that's higher up. The higher up one was f, so we multiply that by the derivative of f. Minus high, that's the top function. D low, that's the derivative of the bottom function. That gives us what goes on top of our fraction. On bottom, we square the fraction, and away we go. Okay. Now, the beauty of that is because low rhymes with go, I remember what order I'm subtracting in. Because low d high minus high d low, square the bottom and away we go. Oh, there's a lilt in my voice and a spring in my step. Listen to how bad it sounds if I get it wrong. If I were to reverse that, high d low minus low d high, square the bottom, away we go. Doesn't rhyme. Doesn't feel right. So if I remember that it's away we go, I've got to rhyme with go. Got to be subtracting the high d low. Okay, that's the quotient rule. Okay. Now, again, the derivation for it we can do is very similar to what we did with the product rule, and we will explore that in some way, shape, or form. But I want to just focus right now on practicing using it. So let's say I wanted to take the derivative of x squared minus 5x divided by 2x plus 3. Now that's kind of interesting because this is a rational function. It's just a polynomial divided by a polynomial. If I were multiplying two polynomials, the result would just be a polynomial. I really wouldn't need, if I were connecting them with multiplication, I wouldn't need the product rule because I could just do the multiplication. But when I'm dividing, a polynomial divided by a polynomial doesn't necessarily give me a polynomial. So even though top and bottom are the same type of function, I still need the quotient rule. Okay, so I'm going to work it out. And again, I don't like to multitask, so I'm going to remember the quotient rule, which involves reciting the poem, okay? And then I'll go back and evaluate the derivatives of the individual parts. Okay, so let's see. This is going to be low. That's 2x plus 3. Notice that goes in parentheses because it had two terms. That whole thing is going to get multiplied by d high. D high, that's the derivative of the top, x squared minus 5x. Minus low d high, minus high, that's x squared minus 5x, d low, that's the derivative of the bottom, all over, square the bottom, and away we go. Okay, so let's simplify. We'll go back and get the d by dx's. So that's 2x plus 3 in parentheses, because that whole thing gets multiplied by this derivative, which will also go in parentheses because it's going to have two terms. We're going to get 2x minus 5 minus, in parentheses, x squared minus 5x. And the derivative here is just 2. All over 2x plus 3 quantity squared. Now, if all I asked you to do was take the derivative, you're done. We've gone back and evaluated all of the d by dx's. Okay. So, if you're just calculating a second derivative, I would be fine with you stopping here. Okay. You will sometimes be motivated to simplify things. Sometimes it might be just to check that you got the right answer in the back of the book. If I had to take a second derivative, I would definitely want to spend some time simplifying this. Because right now, I have a product. That's a constant multiple, so it's a product where one factor is a constant. 2x plus 3 squared, that's a product, because that's 2x plus 3 times 2x plus 3. I've got 3 products inside of my quotient. If I wanted to take the derivative of that, that's an awful lot of work. It might be simpler to multiply things out. So I'm going to go ahead and do that, but I'm trying to also communicate what my standards are for how far you simplify things. And I would actually be okay with you stopping here, because there are enough times that I'm going to ask you to do something more with it that it's going to be to your advantage to simplify things, that I'll be able to see whether you know how to simplify at those times. If we do multiply this out, I'm foiling out the top, so that's going to become 4x squared minus 10x plus 6x is minus 4x, and then minus 15. And now I'm going to distribute the negative and the 2 at the same time. So that's going to be minus 2x squared, and then plus 10x, all over 2x plus 3 squared. I'll often leave things like that way, but if I wanted to actually FOIL that out, that's going to be 4x squared plus 12x plus 9. Now on top, I've got some like terms, so I can combine them. Looks like we've got 4x squared and a minus 2x squared, so that's going to give me 2x squared. Minus 4x plus 10x is plus 6x minus 15 all over 4x squared plus 12x plus 9. Now, if I needed to take a second derivative, I'd much rather have things in that form than in this form. It's going to be a lot easier. All right, one thing I will caution you about, never, ever cancel that with that. You can't, because that 2x plus 3 isn't multiplied by the entire rest of the top. That 2x plus 3 is only multiplied by the 2x minus 5. So the only time you can cancel is if you have something that you can factor out of the entire top, not just the first term.